Okay, let us proceed now the electric field. Example, number 1, a charge positive 7 microcoulomb experiences a force of 3 millinewton in the positive x direction. At a certain point in space, A, what was the electric field there before the charge was placed there? Letter B, describe the force A -3 microcoulomb charge would experience if it is were used in place of the positive 7 microcoulomb. Okay, for letter A, since F is equal to charge multiplied by the electric field in the positive direction, positive x direction with magnitude E is equal to F over the force over the charge, where force is equal to 3 milli. Therefore, 3 times 10 to the negative 3 newtons over the charge. Okay, the charge of positive 7 microcoulomb. Therefore, that is 7 times 10 to the negative 6 coulomb. Okay, where E now is equal to 429 newtons per coulomb. Okay, now for letter B, we have F prime is equal to, letter B is describe the force a -3 microcoulomb charge would experience if it is were used in place of the positive 7 microcoulomb. Instead of F, we're going to use F prime as the symbol. Then we have Q prime times E. Okay, and then, and since Q prime is -3, this one is -3 microcoulomb, F prime is along the negative x direction. Again, since the charge is -3 microcoulomb, therefore, F prime is along the negative x direction. Okay. In magnitude, we have F prime is equal to, okay, Q prime is 3 microcoulomb, therefore that is no need to indicate the negative sign. Okay, therefore, this one is 3 times 10 to the negative 6 coulomb. And then the electric field, which is 429 Newton per coulomb. Okay, cancel the unit. Okay, therefore, this one is equal to 1.29 times 10 to the negative 3 newtons, or that is also equal to 1.29 millinewtons. Okay, and then since your RQ prime is negative, since Q prime is negative, therefore F prime is along the negative x direction. Therefore, negative x direction. And our F prime is 1.29 millinewtons in the x direction. Okay, number 2 example. Example number 2. Find the electric field. at a distance of 0.3 meter from a charge of 3 nanocoulomb. Okay. Solution. Okay, of course, we have electric field is equal to KQ over R squared, where K is 9, where K is equivalent to 9 times 10 to the 9, and then charge is 3 times 10, nano is times 10 to the negative 9 coulomb, then over 0.1 squared, which is equal to, correction, this one is 0.3 meters. 0.3. 0.3 meter. Okay, therefore, this one is equal to 300 Newton per coulomb. This is the final answer. For example number 3. Okay, 3 charges are placed at 3 corners a square as shown in figure below. Find the electric field strength at point A. The requirement is the magnitude and direction. Okay, now for the 3 charges are placed at 3 corners of a square as shown in figure below. This one given is 5 microcoulomb, negative 5 microcoulomb, positive microcoulomb. Find the electric field strength at point A here, magnitude and direction. Okay, given is the side of the square, which is 25 centimeters. Okay, now we have the diagonals 35.4 centimeters since the sides of a square is 25 centimeter. Then therefore the angle is 45 degrees. First, we have to look for the E, where E is equal to KQ over R squared. Okay, therefore we have 9 times 10 to the 9, and then the charge of 5 microcoulomb, therefore that is times 10 to the negative 6. Negative 6 over R, which is 0.25 meter. 25 centimeter converted to meter is 0.25 meter. 25 divided by 100 is 0.25 square. Okay, this one is equal to 720,000. 120,000. Newton per coulomb, or that is also equal to 0.72 mega Newton per coulomb. Mega is times 10 to the 6. Let us get now your E positive, which is equal to, using the Pythagorean square root, okay, square root of square root of 0.72 mega, therefore that is 0.72 times 10 to the, that is your E, and E using Pythagorean, therefore to the 6 squared plus 0.72 times 10 to the 6 squared. Okay, therefore this one is equal to, okay, this one is equal to 1,018,234 Newton per coulomb, or that is also equal to 1.02 mega Newton per coulomb. I just rounded up your 1 into 2 since 8 is the next number. Okay, therefore, your E positive is 1.02 mega Newton per coulomb. So this is the value for E positive. Okay. But the requirement is your electric field strength at point A. A. No, that's this one. This is not yet the final answer. Okay, next. E negative. Now, for E negative, okay, this one is your E negative. Therefore, using the formula, we have K, Q, over R squared. Okay, K is 9 times 10 to the 9. And then your charge is negative, since this one is going to negative by, this one is attract because of the negative sign. Okay, negative 5 micro times 10 to the negative 6 over, okay, the radius, which is 35.4 centimeter into meter, 0.354. Okay, 0.354 meter squared. Okay, 35.4 divided by 100 is 0.354. Therefore, your E negative is, okay, therefore that is negative 359,092 Newton per coulomb. Or that is equal to, since your E positive is in mega, therefore this one is negative 0.359 mega Newton per coulomb. Therefore, RE okay, for E, we have E total is equal to E positive plus E negative. Okay, which is equal to E positive is 1.02. 1.02 meganewton per coulomb plus, okay, this one is negative 0.359. Negative 0.359 meganewton per coulomb. Equal now to, okay, E total is equal to 0.661 meganewton per coulomb. This one is the final answer. Okay, and the direction is, since positive, this one is away from the negative charge, away from the negative charge. Because positive, therefore, repel away from the negative charge. This one is the final answer.